There is a company sitting at the center of the AI revolution. You probably know its name, NVIDIA. Every time a company wants to build a bigger, smarter, more powerful AI model, it needs one thing: more computing power. And for years, that has meant NVIDIA. Its chips became the engines powering the AI boom. From research labs and to the world's biggest technology companies, NVIDIA became the company everyone depended on. But NVIDIA's biggest advantage was never just the hardware. It was everything surrounding it: the software, the developers, the tools, the ecosystem. Millions of people had already built their AI future around NVIDIA. And that created something incredibly difficult to challenge: a fortress, a position so powerful that many believed nobody could break it. But behind the scenes, something unexpected was happening. The people who understood AI hardware better than almost anyone were starting to think differently, because one company had already spent years building an alternative. Google, engineers working, AI models being trained. Narrator: before the world knew the name ChatGPT, before AI became the biggest technology race on Earth, Google was already facing a problem. Its own AI systems were becoming too powerful and too expensive to run. Search, recommendations, language models. Every new generation of AI demanded more computing power, more machines, more energy, more money. Google realized something important. If the future belonged to AI, then relying completely on someone else's hardware was risky. So Google decided to build its own: a custom AI chip designed specifically for machine learning, the Tensor Processing Unit, the TPU. It was Google's attempt to create the machines that could power the next generation of artificial intelligence. And behind those chips, Google was building something even more valuable: experience. A group of engineers who learned one of the hardest problems in technology: how do you build the machines that make AI possible? They learned how to make AI systems faster, how to move enormous amounts of information, how to design hardware specifically for the way modern AI models work. Among those engineers were two people who would eventually take that knowledge somewhere else: Reiner Pope and Mike Gunter. Pope worked on Google's TPU software. Gunter helped design the TPU hardware itself. They weren't simply using AI chips, they were creating them. They understood the technology from the inside, and then they made a decision that would eventually put them on a collision course with the biggest company in AI hardware. They left Google. The timing was almost unbelievable. Around the same period they walked away, the world was about to enter a new AI era. ChatGPT would soon introduce millions of people to generative AI. Suddenly, the demand for AI computing exploded, and the biggest question in technology became: who would build the machines powerful enough to run it? For many companies, the answer was simple: NVIDIA. But Pope and Gunter saw something different. They believed the next generation of AI models needed a different kind of machine, not a chip designed to do everything, a chip designed specifically for the future of AI. So they started a new company. They called it MatX. At first glance, MatX looked like another ambitious Silicon Valley startup: a small team, a huge dream, and an impossible opponent: NVIDIA. But MatX wasn't trying to fight NVIDIA by copying it. They were taking a different approach. The founders believed AI had changed. The models were becoming bigger, the workloads were becoming more demanding, and the machines powering them needed to be redesigned from the ground up. Their goal was simple: build hardware made specifically for the AI revolution. Not yesterday's computers, tomorrow's. Their first major chip became known as the MatX-1. The idea behind it was straightforward: make AI processing faster by designing every part of the system around the needs of modern AI models. Less waiting, more speed, more efficiency, a machine built for one purpose: helping the biggest AI systems run better. But building a better idea is easy. Building a real chip is where the nightmare begins. For any startup trying to challenge NVIDIA, there is one question that matters: not, can you design a chip? Many companies can do that. The real question is, can you build something powerful enough to change the AI industry? And MatX made a very bold claim. The company believes its technology could deliver performance far beyond today's leading AI hardware for certain large language model workloads, around 10 times the training throughput of NVIDIA's H100. Numbers like that sound almost impossible, because NVIDIA's H100 is already one of the most important pieces of technology behind the current AI boom. It powers some of the world's largest AI systems, So if a small startup could actually deliver that kind of improvement, the impact would be enormous. The cost of building AI models could change. The balance of power in AI computing could change. And companies that currently depend on NVIDIA could suddenly have another option. But there is a critical detail. These results are not from millions of chips running inside data centers. They are not from a finished product available today. They are projections, a promise, a vision of what the technology could become. And that creates the biggest question surrounding MatX. Can they turn the idea into reality? Because in the semiconductor world, a great design is only the beginning. Building an advanced AI chip requires something every startup struggles with: time and money, a lot of money. MatX started by raising a $25 million seed round in 2023. Then came additional funding as investors became more interested in the company's vision. But then, something happened that made the industry pay attention. In 2026, MatX raised another $500 million, a massive investment for a company that had not yet shipped its first production chip. That brought the company's total funding to roughly $625 million. And the message from investors was clear. They believed there was an opportunity to challenge the most powerful company in AI hardware. But money alone doesn't create a successful chip, because semiconductor history is filled with companies that had great ideas and still failed. The hardest part was still ahead. Creating an AI chip is one of the most difficult challenges in technology. First, you have to design it. Then, you have to manufacture it. Then, you have to make thousands of chips work reliably. Then, you need companies to trust it enough to run their most important AI systems on it. MatX plans to manufacture its chips through TSMC. But compared with NVIDIA, the difference is enormous. NVIDIA is a global technology giant with decades of experience, thousands of employees, a massive software ecosystem. MatX is a much smaller company, a team trying to transform a design on paper into hardware that can compete inside the world's biggest data centers. And that is where many challengers fail. Not because the idea is bad, but because the execution is almost impossible. And even if MatX creates a powerful chip, there is another problem, a much bigger one, because NVIDIA's dominance was never only about the hardware. The real advantage was everything built around it, a world called CUDA. For years, millions of developers have built their AI software around NVIDIA's ecosystem, the tools, the libraries, the frameworks, the systems that make AI development possible. This created something extremely valuable, a habit, a dependency, a reason for companies to stay. Because replacing a chip is one challenge. Replacing an entire ecosystem is another. And this is the battle every NVIDIA challenger faces. They are not just competing against a piece of hardware. They are competing against years of trust, software, and developer experience. MatX understands this. The company knows that creating a faster chip is not enough. It needs to convince AI companies that there is another path, a path away from NVIDIA. And interestingly, MatX is not alone. The most surprising part of this story is where many of these challengers came from: Google. For years, Google invested heavily in its own AI hardware. Its TPU chips helped power Google's AI systems. And while building those systems, Google created something even more important: a generation of engineers who understood the future of AI hardware. Some stayed, some left, and some decided to build something of their own. MatX is one example. Other startups connected to former Google engineers are also exploring different ways to challenge NVIDIA's position. Different companies, different strategies, but one common goal: break the idea that there is only one company capable of powering the AI revolution. And that creates an interesting irony. Google spent years building alternatives to NVIDIA, but while doing so, it also trained some of the people who may one day challenge NVIDIA themselves. NVIDIA is still the king of AI hardware, and MatX may still fail. Its biggest promises have not yet been proven. Its chips have not reached the market, and the hardest battle is still ahead. But something important has already changed. For years, NVIDIA's dominance looked unstoppable. Now, a new generation of challengers is emerging, and many of the people building those challengers are not outsiders. They are engineers who helped create the technology powering today's AI revolution. They learned from the giants. They worked inside the biggest companies. They helped build the future. And then they walked away. Google taught them how to build the machines. Now they are trying to build a machine of their own. Because technology empires are rarely challenged by strangers. They are challenged by people who understand them better than anyone else. And perhaps that is the biggest threat to any powerful company. Not someone trying to destroy the system from outside, but someone who helped build it and decides to create something new.